Hello viewers, I am Harshita Gaur and today, along with my friend Priyanka Gogoi, we are the students of Barak Valley Engineering College, Sribhumi, Assam from the Department of Electronics and Telecommunication. So today we are going to present an innovative solution to one of the world's most pressing environmental problems, plastic waste. Introducing BioBin, a compact, user-friendly waste management system designed to break down plastic using plastic-eating bacteria. It's not just a bin, it's a mini lab that uses science and nature to transform harmful plastic into harmless byproducts. So here's the agenda. These are the points that we are going to discuss over the presentation. It starts with problem statement. We have the objective, solution overview, scientific basis, biobin design, workflow, uses cases and impact, challenges and limitation, future scope, and at last the conclusion. Every year, millions of tons of plastic end up in our oceans, landfills, and natural habitats. Despite recycling efforts, most plastic still doesn't get properly disposed of. Traditional methods are often expensive, energy consuming, or inaccessible to everyday households. So, we asked ourselves, can we manage plastic waste in a smarter, eco-friendly way right from our homes? So, moving on, we have objective of the project. Our objective is clear: to develop a compact, user-friendly system that decomposes plastic at the household level using naturally occurring or engineered bacteria. We aim to reduce the volume of household plastic waste, turn plastic into harmless or reusable byproducts, promote eco-friendly or eco-conscious behavior, offer a low-cost and sustainable alternative to industrial recycling. Next, we are moving on to the solution overview. Introduction to the BioBin. Meet BioBin, a smart, eco-friendly bin designed to break down plastic waste right at home. The key features are: it uses plastic degrading bacteria, operates in a controlled microbial environment, converts plastic into non-toxic residues, operational features like solar panels and app connectivity for a smarter experience. The scientific basis is that the core of BioBin lies in microbial plastic degradation. We use bacteria like Ideonella sechensis, known for breaking down PET plastic, Pseudomonas species effective against various polymers. These microbes naturally consume plastic, converting into safer byproducts. So for this, we have also designed a special temperature and pH maintaining environment in our BioBin. So, it provides a suitable environment for the bacteria to survive. Next, we have the BioBin design. The BioBin consists of a shredding unit to break down plastic into smaller pieces so that there is more surface area to collect the plastic waste, and also it shreds the plastic waste into small pieces for easy decomposition. A bacterial chamber where biodegradation occurs, sensors to monitor and optimize pH, temperature, and humidity. So it creates the suitable environment for the bacteria to survive. A waste tray to collect the byproducts, and at last, solar panel and mobile applications options for energy efficient and connected operation. So after this, I would like to request my friend Priyanka to carry on the presentation and also explain to us the rest of the product design. Thank you.
Thank you, Harshita. Now that we have covered the first step, I will walk you through the rest. Let us now explore the workflow of the BioBin system in details, a seamless yet scientific process that transforms harmful processed waste into harmless byproduct through microbial action. So here the first step. Incineration of plastic waste. The process begins when user deposit clean dry plastic waste such as bottles, wrappers, and packaging materials into the BioBin, and it is crucial that the plastic is pre-planned to prevent and ensure optimal condition for bacterial activity. Furthermore, shredding mechanism. So once inside the bin, the plastic waste is automatically directed to a shredding unit. The components break down the plastic down into smaller fragments. This step is critical as it increases the surface area of the plastic and thereby enhancing the microbial access and accelerating the biodegradation process. And furthermore, initiation of biodegradation. The shredded plastic is then introduced into the bacterial chamber, the core of the biobin system. These chambers contain specially selected strains of plastic regarding bacteria that begins breaking down the complex polymer present in plastic into simpler, non-toxic components. The chamber maintains a controlled environment to optimize microbial efficiency. So furthermore, sensor-based monitoring and environmental control. So in here, we ensure the ideal condition for bacterial activity. The biobin is equipped with a sensor system that continuously monitors key environmental parameters such as temperature, pH, and humidity. So in here, the parameters are automatically regulated. Then it ensures that the decomposition process remains both efficient and consistent over time. And last, progression decomposition. Over a period of time, which may vary depending on the type and amount of plastic, the bacteria gradually decompose the plastic material. So unlike traditional degradation methods, this process does not release harmful byproduct or microplastic, thereby ensuring environmental safety. So next, collection of byproducts. In here, the plastic breakdowns, the resulting residues, which are non-toxic and biosafe, are collected in a separate waste tray at the bottom of the bin. This byproduct may be disposed of safely or, where applicable, utilized as composting material or in a further recycling initiatives. So moving on to the final component, digital monitoring via mobile application. An application that is beneficial features of biobin. It is an integration with a mobile application, and user can monitor the progress of the decomposition process in real time and also receive alerts on operational status and access data on the volume of plastic processed, thereby promoting user engagement and transparency. So furthermore, the biobin system is designed with versatility and social impact in mind, making it suitable for deployment across a variety of environment and demographics. So in residential homes and apartments, biobin offers households an efficient, responsible way to manage their daily plastic waste. It empowers individuals and families to contribute meaningfully to environmental prevention and to the adding comfort of their own homes. Following that, in educational institutions, schools, colleges, and universities can incorporate biobin not only as a waste management tool, but also as an hands-on educational resources. And students gain practical exposure to sustainable technology, also microbial science, environmental awareness from an early age. Following that, in rural and off-grid areas, equipped with an optional solar panel, biobin can operate effectively in areas with limited or on access to grid electricity, and it makes it particularly impactful in rural and remote regions where waste disposal systems are often non-existent. And in smart cities and urban infrastructure integrated into urban waste management system, biobin can serve as a decentralized tech-enabled solution for plastic segregation and treatment. So moving on, future scope. While biobin already presents a compelling solution, its potential for evolution and scalability is vast. Let us look at the future scope of this project. First, bordering bacterial capabilities. Ongoing research can introduce new strain of bacteria capable of decomposing a wider range of plastic types, including low density and other resistant polymers. Accelerated decomposition. With the support of genetic engineering and enzyme research, future vision of biobin may achieve significantly faster degradation rates, thereby improving efficiency throughout. So moving on to the next Scalability and community models. Larger scale version of the biobin can be developed for use in hotels, apartment complexes, and even municipal level facilities. Enable community-wide waste processing without the need for large centralized plants. So moving on to the next point, we have integration with IoT and data analytics. By incorporating advanced IoT features, biobin can provide real-time tracking, predictive maintenance alerts, environmental impacts, analytic and user feedback, transforming it into an intelligent data-driven waste solution. So the last point, by product utilization, the harmless residue produced after plastic breakdown can be further studied and proceed into useful products such as biofertilizer, construction material, additives, or even biofuels, thereby adding further value to waste. So, in conclusion, the plastic crisis is not just a matter of pollution, it is a challenge to human responsibility, scientific ingenuity, and global cooperation, but in this crisis lies an opportunity. And biobin is more than a product, it is a symbol of what is possible when innovation meets purpose. It brings together the power of microbial science, sustainable engineering, and digital technology to create a practical solution that begins at the individual level and scale to community impact. So let us embrace this solution not as just a tool but as a movement, a step forward in returning waste into world and problems into progress. Together we can transform how we can think about plastic not as an end but as an beginning. Thank you, and if you have any queries, reach out to us.